So up until this point, we've been evaluating trigonometric functions using special right triangles, the 30, 60, 90, 45, 45, 90. And that's worked okay. But that's assuming that our input into the trig functions are angles. And that's what we've been dealing with. Anytime we had a trigonometric function, we've always been taking the sine of 30 degrees or the cosine of 2 pi over 3 radians. They've always been angle measures, correct? Okay. Most applications, especially in physics and in the real world pretty much, most applications of trigonometric functions don't deal with angles, they deal with real numbers. So we need to look at how to define trigonometric functions when the input is a real number. So here's what I need you to do. Draw a graph. On the graph, I'm going to draw circles centered around the origin. And this is the unit circle. What does it mean to be a unit circle, by the way? Have we talked about that? I don't think we have. What does it mean to be a unit circle? It has something to do with its radius. The radius is 1 unit long. So let's define that. From here to here, you can't even see that. From here to here, that's 1 unit. That's why this is called the unit circle. Now, if I say the phrase real number line, what's coming into your mind right now? If I say the phrase real number line, what are you imagining in your head? Real number line. What's the real number line? A number line, a horizontal line with tick marks. Is that what you're imagining? Okay, this is usually how we think of the real number line, correct? Okay, we're going to draw the real number line vertical. So draw a line on the right side. Ooh, look how perfect that line is. Whoa! Marvel at the beauty. Now label that as the real number line. Where we have 0, and then 1, and then 2, and then 3, negative 1, negative 2, negative 2. We're also going to be making use of this. Hopefully you recognize this because you just barely finished the test on it. What is this? This is the length of an arc. Okay? Now, the length of an arc is radius times the angle measure. But on the unit circle, what's the radius? The radius is 1, right? So if I talk about the length of an arc around the unit circle, isn't that exactly the same as the radian measure of that arc? You guys understand what I'm talking about? Okay. So we're clear on that. The radius is 1. So on the unit circle, S is equal to theta if it's in radians. The arc is equal to the radian measure. What I'm getting at is how is it that we're going to be able to take the trig functions of real numbers when all we've been able to do is to take trig function or evaluate trig functions of angle measures. Let's take this number. Now this doesn't even have to be labeled. I actually haven't labeled this according to scale. So I'm going to take off these labels. I just put them on there so you got a sense of this is the positive direction going up, this was the negative direction going down. If I wanted to go that far on the number line, that point that I placed on the number line, that point represents a real number. Would you guys agree? Now since I haven't labeled the number line, we don't know what real number it is, but this point represents a real number line, and it's a positive number because it's going up. This is a real number. How can I take the sine or the cosine or the tangent of that real number?
Draw an angle to it.
Exactly. Okay, now draw as neatly as you can here on this. If I took this exact same linear distance from 0 to that real number and wrapped it around the unit circle so that the arc length was the same as that linear distance. Let's call it from here to here, let's call that a length of r. If I took that length and wrapped it around the unit circle here to here, that also has a length of r. So what we're doing using the unit circle is taking any real number and just wrapping that real number around the unit circle. Why would we want to wrap that real number around the unit circle?
Find the arc length of that.
Because now we can find the arc length. From here to here, isn't this an arc length?
Yeah.
But on the unit circle, what is the arc length? It's the same as the radian measure. Okay? And why are we so concerned about turning this into a radian measure? The way that we've defined sine and cosine is we can only take or evaluate trig functions of angle measures. Well, we can take any real number and turn it into an angle measure, so to speak, by wrapping it around the unit circle. Does that make sense? So we're still following, to some degree, our definitions of sine and cosine and tangent, where we the input are angle measures, as long as we consider this real number to be a radian measure wrapped around the unit circle. Okay? Now, how would we find, then, the sine or the cosine or the tangent of that point? Let's consider this point right here that we're using. What do you think? How would we find the sine or the cosine or the tangent for that matter? We know that the length from the center to here is 1 because it's a unit circle. Now, doesn't this point have an xy coordinate? Because we're drawing this on a graph. That point has an xy coordinate, right? Okay, where's my little thick bow? Here it is. That's so handy. What is it from here to here? What's the measure of that angle? R, right? The arc here, from the x-axis up to that angle, that's an arc length of r. But on the unit circle, the arc length is the same as that radian measure, so we have r right there. So what if I wanted to do the sine of that real number r? Isn't this a right triangle, you guys?
Yeah.
Now don't get confused. This little r right here actually should go right there. Okay? What is the length of this vertical component of that triangle? Whatever the y coordinate is. What's the length of this horizontal component of that triangle? Whatever the x component is of that point. So again, what's the sine of that real number r? What's the definition of sine on a right triangle? Opposite over hypotenuse. But in this case, the hypotenuse is 1. It doesn't really matter if you divide by 1. Okay, so let's just discount. We're not consider that hypotenuse there. What's the definition of the sine of that real number on this triangle right here? It's the y part of that point. So sine of r, that real number, is equal to what? What about the cosine of that real number r? Say again, Trent. It's the x part of that point. What about the tangent of that real number r? It would be y over x. That's assuming x does not equal 0. Do these definitions look slightly familiar to something we learned about in chapter 6? Wasn't sine equal to y divided by r? Why are we dividing by r here? Remember r, the way we defined it then, r was the length of that hypotenuse. And here, r was the radius. Here it's 1. Okay? These are the definitions right here. These are the definitions of sine, cosine, and tangent on the unit circle. These are the definitions of sine, cosine, tangent on the unit circle. Now we're treating the input r not as angle measures anymore, but as real numbers. But these real numbers can be wrapped around the unit circle to form a radian measure or an arc length. And really, this is all you're going to have to do on lesson 5.2. Evaluate. I'm going to go through a bunch of examples here. These are now meant to be done using the unit circle. So I would recommend you print this off before starting this assignment. These are meant to be done using the unit circle now. These are. Okay? Remember, 2 pi over 3, this is a real number. It's not an angle measure anymore, but we can take that real number and wrap it around the unit circle. Where would that real number 2 pi over 3 be wrapped around on the unit circle? It would be wrapped around that exact same length, the 2 pi over 3 radians. Because the arc length of 2 pi over 3 on a unit circle is the same as that radian measure. Yeah, so all you have to do is, if you're evaluating the sine of 2 pi over 3, you have to locate, can you guys see that? You probably can't hear me. There you go. All you have to do is locate that radian measure of 2 pi over 3, which is right here. This is 2 pi thirds. And then you have to remember the definition of the sine function on the unit circle. What was definition of sine? It was the y coordinate there. So here's a point on 2 pi thirds. And the y coordinate is the square root of 3 over 2. So what's the sine of 2 pi over 3? Square root of 3 over 2. The sine of 2 pi over 3 is the square root of 3 over 2. We don't have to use reference angles or special triangles. Cosine of 7 pi fourths. Just got to find 7 pi fourths. Now if 7 pi fourths at an arc, that would wrap itself all the way around to right here. That would go 3/4 of the way around a unit circle, which is exactly equal to the radian measure of 7 pi over 4. What's the definition of cosine on the unit circle? The x. So all you have to do at 7 pi fourths is locate the x part of that coordinate. So the cosine of 7 pi fourths is the square root of 2 over 2. Notice what we also don't have to worry about anymore. Do we have to worry about that all students take calculus? It's already done for us. Okay? It's inherent in the locations of these points on the unit circle. Okay? Notice all the x values in the fourth quadrant are positive. The cosine is equal to x, and in the fourth quadrant these are all positive, so the cosine is going to be positive inherently here in the fourth quadrant just by using those points. Okay? So you don't have to worry about, well, is it positive, is it negative? That's only if you're using reference angles and special triangles. Tangent's the one that takes a little bit more work. You have to divide the y by the x. Tangent of 5 pi thirds. Okay. 5 pi thirds is here. The tangent, though, is the y value divided by the x value. So it's negative square root of 2 divided by 1/2. Negative square root of 2 divided by 1/2. Exactly. Exactly. Dividing by 1/2 is the same as timesing by 2 over 1. 2's cancel. And you get negative square root of 3. Again, does the answer make sense that it's negative? Yeah, because it's in the fourth quadrant. Tangent's negative there, but we didn't have to put the negative in there. It was already there. So that's really all your assignment is going to be, is evaluating. Now, I didn't tell you the other three. You are going to have to do cosecant and secant and cotangent. What would those definitions be? Be 1 over y, 1 over x, and x over y. Let's just do a quick example of one of those. Example 2, then we'll be done. Let's do the secant of 7 pi over 6 and the cosecant of negative cosecant of negative 3 pi half. Seven pi over 6, remember this represents a real number, but you wrap that real number around the unit circle, and that's equal to the radian measure of 7 pi over 6. So locate 7 pi over 6. 7 pi over 6 is right here. Now, the secant. Is it secant or were we doing cosecant? Secant. The secant is the reciprocal of the cosine. So the secant is going to be 1 over x. So at that point, it's going to be 1 over, or 1 divided by negative square root of 3 over 2. One divided by negative square root of 3 over 2. It's just a reciprocal, exactly. All this is a reciprocal. So this is negative 2 divided by the square root of 3. And then you rationalize it. Negative 2 square root of 3 over 3. Negative 3 pi over 2, negative 3 pi over 2. This is still representing a real number, you guys. Okay, let me go back to this real quick. If the real number is positive, then on the real number line, it comes up this way and it wraps itself counterclockwise. If the real number happens to be negative, which in this case it was at negative 3 pi over 2, the negative 3 pi over 2 would be down here on the real number line, so it would have to wrap itself clockwise. Okay? And all that really means is we're locating that angle in the clockwise direction because it's negative. So on the unit circle, where is negative 3 pi over 2 radians on the unit circle? 3 pi over 2 would be going around this way, 3/4 of a circle. So going the other direction would be going this way. Okay. If we go negative 3 pi over 2, that's coming up here. So we have to locate that point. 0, 1. Yeah. The point is 0, 1. X is 0, y is 1. Now we're doing cosecant, which is 1 over y. But what's the y value at 90 degrees, or pi over 2, or negative 3 pi over 2? What's the y value there? The y value there is 1. So it's 1 divided by 1, which is 1. The cosecant of negative 3 pi over 2 is equal to 1. Yeah.
So if it would have been like 180 and y equals 0, would that just be undefined?
Did you guys hear that? What if it had been the cosecant? This is a good question. What if it was the cosecant of pi? Is that what you were asking?
Yeah.
What's the cosecant of pi? Well, the definition is still 1 over y. And if you look at the unit circle, pi radians is right here, but the y value is 0. So it would be 1 over 0, which is undefined. So you just answer that as undefined. That will happen a number of times on your homework. Okay?